Record it while I'm doing this, so you guys can have access to the video later of me embarrassing myself. Okay, so 1.5 times 1/4. Okay, a lot of people find that multiplication is much easier to do than division. It's just something that we're used to. But actually, division makes things seem a little bit more clear, because I can't visualize how I would take a box and then I take half of it. Okay, and then I take that half and I multiply it by another box that's cut into quarters. And like, I don't see that visually. That doesn't make, like, I don't know if that makes sense to you guys, but that's essentially what you're doing. You're taking half a box and multiplying it by a quarter of a box to get an eighth of a box. That's visually, that is not appealing. It doesn't make too much sense. Okay, this is not a good representation of how you're doing that math. So instead, I like to visually, I like to think of things as division all the time. That's just how my brain works. So, while you guys are just like, just do the numerator and denominator, that's not actually how my brain works. My brain works way differently, and it took me a while to figure this out, because I'm not the same as most people when it comes to math, and it's actually why I'm quite good at math. Just because I took a second to myself and I actually figured out why I know math works in this manner. Okay? So instead of thinking like this, I know I could write 1 divide or half. And just like you guys do the division thing where you flip the second fraction, I do the exact same thing. I turned it into a division problem by flipping the fraction. So instead of thinking of dividing or multiplying by a fourth, I divide by 4 instead. And it's the same thing. Like, it, you think it's not, but it is. I just turned it into a division problem. And you're like, why would anybody ever want to do that? Well, the answer is pretty simple, because I can think in my brain physically. I can think I have half a box. Okay? And instead of thinking of a second box that's cut into quarters, now I could just take that visual representation and say, oh, what if I just divide it into 4 more pieces all the way across? My bad. Like this. What if I cut it into 4 pieces instead? Okay. If I cut it into 4 pieces, I just want one piece. This one area right here. Then I know I have one piece out of 1, 2, 3, 4, 5, 6, 7, 8 pieces. Okay. And that's why I think division. Okay, Alec, you can wait on sending the picture. You don't have to send it this second. If you can't, you can always or you can always send it to me later. So that's why I think of everything in terms of division and not multiplication. Okay? Because multiplication, when you're thinking about it, when you're using multiplication, you use multiplication when you need to add quickly. Okay, that's why you use multiplication. You only use it when you need to add quickly, and I'm not adding two figures together. Okay, that's what a lot of problems are with divisions with fractions, is that you're not always adding two objects together. Sometimes you're doing this, which isn't taking two objects and shoving them together. Instead, you're using division, and this is why division is so powerful. You use division to separate. Okay, use it to separate. That's why you use division. That is like a big thing for a lot of people, and they don't. You guys probably still are having issues understanding what I'm telling you because you probably hate division. But division is a very powerful thing, and we use it all the time. It's just that we don't use it in the way that you think we use it. You think that division is shoving one object into another, but it's not. It's always using to separate. So if we look at the third one, the fourth, the bottom right now, we're doing 1/2 divided by 1/4. Okay. Again, if you try to do this where you have two boxes and you're trying to shove them together, it makes no sense. Okay. Visually, you're like, how does that work? How do we take one object and divide it into another? Which is why I'm saying you can't do that. Okay. Most of you guys are like, why not? It's just two objects. But in reality, you guys would just flip the 4. But in this case, I wouldn't flip the 4. Instead, in my brain, I would still think of it as 1/2 divided by 1/4. Still, alright? Still. And then I would draw out my boxes again, just like as if they were normal boxes. Well, I just need one box. I'm not thinking of two boxes. I'm thinking of one box that's split in half. Okay. But now, I want to know, using half that box, okay, and divide it into quarters now. So I need 4 pieces. I need this whole box to turn into 4 pieces rather than 2 pieces. So I think of this line right here again, that one, and I also think of this line. Now I have 4 pieces, right? And they're just asking me from the original half, this one, how many are still white in the 4-piece setup? That's the question that this is asking. How many shaded, so the white shaded area, are in the 4-piece setup. Okay, rather than, we're not separating in this case because it's not a whole number, it's a fraction. My answer here would be, there are 2 right there. There are 2 of them. There's 2 boxes. 1, 2 in the 4-piece setup. Here and here. Okay? That's the difference between the 2 areas. Just so you know.